we get started?
Yeah.
What are the resources we have and how best to use them?
Distribute.
Ja,
hej everyone!
Till mig.
Aha.
När jag börjar få sluta.
Ja, förlåt. Okej, när det slutar?
Ja, precis. När det liksom börjar få sluta.
Ja, ja.
Okay, great. Feels great to be here. Thank you for inviting me. My name is Karim Nevari, and I work at the Institute for Future Studies, where I'm a postdoctoral researcher. And my background is in philosophy, and my work is mostly in applied ethics. I've been very interested in the ethics of technology, and recently, or the last 2 years, I've been thinking about AI risk. And I started with these kind of really big issues, like if you talk about superintelligence and so on. But now I've also kind of diversified my portfolio into more near-term AI risks. So I'm trying to cover that. And I've been talking a lot about risks, and I felt I was a little bit tired of it. So I think I'm going to emphasize the potential of AI today. But it's kind of inevitable that we get into the risks. So I'll mention that. And I think the tagline for my talk, if it helps you remember it, is that amateurs talk about strategy, professionals talk about logistics. And I will explain what I mean by that in a moment. But that's kind of the tagline. Okay, so as I understand, you're all, or most of you at least, have very useful skills. So you're either AI programmers yourself, or you have worked in programming and are kind of learning about AI. And that, I think this is a great thing. We need those skills, but we also need to put them to good use. As was mentioned previously, when thinking about effective causes, so you can think about how to effectively spend your money, and then you can think about, like, should I give to malaria nets or something else? But you can also think in this kind of effective altruist way about your own careers, or about your own, how to apply your skills. And in one respect, your skills might be, at least at the moment, seeing that most of you are quite young, more valuable than your money. Well, because you probably don't have that much money. Yeah. So, but you will in the future, I'm pretty sure. But you have skills, and most of all, you have great opportunities to develop those skills. So going back to this threefold way of thinking about effectiveness that I discussed to, scale, neglectedness, and solvability. I will propose that there's one field that is largely, well, to a great extent, been neglected by AI programmers or computer people in the West, and that is the state. And I think, and one of the insights I think I've got from following the EA movement is that sometimes we neglect things because doing those things pulls us out of our comfort zone. So lots of people who work with international charities, they're not very quantitative people. You know, they like the human touch, the relationship. And thinking about maths and statistics makes them uncomfortable. And when I talk to them about, you know, you have to compare cost effectiveness, you have to see the statistics of the bars, they feel uncomfortable. And I think, well, yeah, it's too bad that they feel uncomfortable. That's not my point, but I think it's an indicator of that this is likely something that they've neglected. And I think what a lot of people in the IT community feel uncomfortable about is politics. So maybe this is a kind of stereotype about you, but you'll have to endure it for a while. So why do I say that it's the state or politics is so important? Well, going back to the tagline, amateurs talk about strategy, and professionals talk about logistics. It's an expression to say that, you know, when we talk about why a war was won and another war was lost, we often tend to emphasize the battles, the courage, the men that did like smart things and maneuvers on the battlefield and so on. But in the end, what has won most wars has not been like really good skills in the battlefield, neither for generals nor for individual soldiers, but the logistics. Where were the human and natural resources applied? Could this state mobilize more resources than this other state? Could this state secure the transfer of resources from, say, the mines to the hands of their soldiers? So logistics is what wins wars. And I think in the end, logistics is what matters. The knowledge and the capacity to mobilize resources to achieve a certain end. And of course, if you think about the history of mankind, states, in one form or another, states is of course a political machine that has greatly evolved throughout the millennia. But the primary function of a state is to mobilize human and natural resources. And the way the state does this, I mean, we started doing this already in the Roman era, is by gathering and manipulating information. So you might know about the Roman office of the censor. The censor was the person who did the census. He counted the people, and there was a very, very detailed assessment of how many slaves you own, how much farmland you own, and this could be used to tax you, to draft your sons, and perhaps to demand land or something else. So by having this rich source of information that was frequently updated about its citizens, Rome could mobilize resources like no other state in its time. And many people believe that this is, I mean, Rome was lucky in some respects, but many believe that this is what made Rome a superpower. Okay. And the history of how states evolved and became more and more powerful and more able to mobilize human resources is also the history of how information technology or political technology evolved. And you can see it at the last Great War, the Second World War, how information technology was used to its fullest to mobilize and retool the economies of the world to produce weapons of war, but also to draft citizens and put them to use, not only in the battlefield, but also in the factories. And to this end, a lot of the statistical techniques who have been developed in the early 20th century, like linear regression and other mathematical tools, with the new computers that were also emerging, were used to their full potential in many countries. So what I'm trying to say here is that when a lot of the people in the tech community and people who are kind of the tech hang-around community, fans of techies, talk about AI and talk about tech, they often suffer from what I like to call a front-end delusion or a front-end distraction. So we like to talk about apps, we like to talk about robots, we like to talk about cool web pages and cool products. And I mean, all these things are really cool. I mean, you know, you can have a machine that can measure certain amounts of proteins in your blood that you can improve medical diagnostics a little bit. But I think that the kind of main, huge, low-hanging fruit, the task that is both neglected by tech, but also that has a huge scalability, is to fully implement these new AI technologies that we've been seeing coming out in the last 10 years into the roles and hands of the administrative state. And I think, so I think that's like a huge neglected issue. And let me just exemplify. So, according to the World Health Organization, about 50% of the population in OECD countries is likely to suffer from mental illness at some point in their lives. 50%. Okay? This is the main health challenge of rich countries. It drops people from the most productive years of them. It's also the #1 killer for young men. It also leads to a lot of secondary harms, such as alcohol abuse, violence, and so on. So to address mental disease, we really need to, that should really be the highest health priority in the wealthy. The problem with mental disease is that to address mental disease, you need to get the sick people to a psychologist or to the clinic where they can get medicines and therapy. The problem is the symptoms with mental disease is that you're not likely to want to go to a clinic, right? You want to just sit in your house and stay in bed. That's kind of the first symptoms of depression or of severe anxiety. So our whole medical system is based around the premise that if you are sick, you are going to be motivated to go to the doctor, like if your leg is broken. But this is not the case with the #1 health challenge in rich countries. So this is just an example of how the administrative state could, by having information about its citizens, could use that information to address or treat the #1 health challenge. So by knowing who is sick or who is likely to become sick in the future, we could do early interventions in childhood and follow people and make sure that they don't fall behind, or they don't kind of start doing these kind of very destructive habits that makes pulling someone from depression really difficult if they already have like a severe alcohol addiction and have lost all their skills because they dropped out of school. So that's just an example of how a new level of knowledge, detailed knowledge about citizens, could allow the state to address major public health problems. So that was kind of a concrete example. Let me kind of zoom out and say something about what will happen if we don't do this. Well, so first I can say what's going on now when techniques are not doing it. It's that there are other people who talk about digitization. And some of you might be thinking like, hey, I hear people talk about AI and digitization all the time. How can you say that this is neglected? Well, the thing is, I talk about these things every day. And this is just anecdotal evidence. But every time I get to some place to talk about this, I'm confronted by people who have no idea what they're talking about, yet they label themselves experts. And sometimes there are management consultants, they might be economists, they might be salespeople, public relations experts, and so on. And they've read like Ray Kurzweil, they've read maybe Max Tegmark, they've maybe read Nick Bostrom, they've seen lots of TED videos, and they think they know what AI is, and they're just babbling, and they're not saying something concrete, they're just hyping, they're just saying this is the future, and you need to be on it. And I think that's what happens when you, I think fewer of those people should be there talking to the municipalities and to the bureaucrats, and there should be more of people who are actually working with AI and know what to do and how to solve a particular problem in a municipality. And I think that another aspect of so I think that's what's happening now. But I think in the long term, what we're seeing is that many Western countries are kind of in a state of technological stagnation. Not the technology is there, the science is there. The problem is that the Western countries are just not interested. Politically speaking, the political system is not interested in using this technology. It's for a variety of reasons. So in Germany, for example, you have a history of a very ruthless surveillance state, and also a long history of anti-science and technology romanticism that fuels that. I think this is my amateur anthropological analysis of why Germany is still in this Stone Age. But we have many other countries where there's been this kind of huge growth in the bureaucracy in the years after the war. And that growth in the bureaucracy coincided with a certain technology. And that in itself is kind of very slow moving. You would have to perform so many systems, so it's kind of there's this huge inertia. But I think kind of the main reason why we have this relative backwardness or relative disinterest in technology is because there seems to be lacking a degree of crisis, a degree of necessity in countries in the West. I think we're in many ways complacent. And I think we're not seeing this in East Asia, where there's a fierce and intense geopolitical competition, a situation where the Japanese feel that unless they develop, unless they kind of mobilize all the resources available to them, the Chinese will steal them. And this is what Koreans are thinking, and what Chinese are thinking, and Taiwanese, and Singapore. And you can see, I mean, this is also I'm kind of speculating. I think there's an element of this, probably not the whole explanation. But what we can see is that these countries are really doing everything that they can to integrate AI technology into their political systems, to try to absorb AI technology into the functioning of the administrative state. And of course, I mean, it's not a walk in the park. Of course, it's never done. But we're already seeing a lot of results. Its e-sales are way higher in China per person than in Europe. In Korea, we have a lot of smart systems that help with congestion and with other problems in mass transit. So it seems to me that what could happen, unless Western democracies do something, is that the center of power is going to shift faster to China than it would otherwise. I think maybe it will end up there anyway. I mean, it's not like I don't believe in history is already written and so on. But I think the trends are not only when you look at the capital and so on, but in the trends in how they see technology. And if the technology, information technology, AI is as powerful as I think it is, then that's a sign that's much more worth in itself than the fact that China has strong growth. I mean, China has strong growth for a lot of reasons, but one of the reasons is that it's just used to be very poor, and going from a situation where we were very poor to a situation where we were moderately poor, there are good opportunities for people. I think that there are other trends in China's economy that we should be more concerned. And why am I so concerned now about this? Is it something wrong with China? No, it's nothing wrong with China as a country. The problem is that the political system that they represent and the influence that they can exert, that they could exert, would they be a superpower like the US, would be, I think, very detrimental to my kind of ideal of how the world should look like. It's not like I'm really like pro-America. I think the US is really bad in many respects. But I think that if China was the superpower rather than the US, that the world would be worse than it is. So I think if I can have another tagline, and taglines are good because it's kind of captures our imagination and it's for remembering stuff. So another tagline is this: we need a Sputnik moment. And you might know this kind of phrase, Sputnik moment. It's from when the Soviet Union launched their first satellite, Sputnik, and the American intelligentsia cracked themselves because they were like, oh shit, the Soviet Union is ahead of us in space technology, and this is a new technology frontier when it comes to weapons. And then they got their shit together and they started NASA, they started DARPA, they started programs, they started the Advanced Center for Advanced Studies at Yale. They implemented the B1 visa. Well, the Genius visa that attracted lots of talent from all over the world to work on the most difficult problems. They funded a lot of research all over the country, and they built up the best education system and research system in the world. Was maybe already on the way, but the Sputnik moment really catalyzed this. And they realized that we need to invest in research and development, and we need to have a bureaucracy that is responsive to new technology that can pick this up. And the Sputnik moment really helped. I mean, the US not only outcompeted the Soviet Union on an economic level and geopolitical level, but also on a technological level. Even though the Star Wars was hype, and sometimes hype really works, not in the way you intended it. Star Wars was really hype, but they were so advanced that the Soviet Union actually bought it. You know about Star Wars? Yeah, well, it was a system that they claimed to shoot down intercontinental ballistic missiles. Okay, so what are the risks then? So I already talked. So yeah, that was the opportunity of AI, and I think what you can contribute to that by thinking about how could this part of the state, let it be a municipality, a county, a system of delivering welfare, a system of extracting taxes or whatever, be improved by the technological skills that I have. How can data analysis improve the targeting of whatever it is? So that's kind of summarizing that part. What about the risks? Well, I already mentioned one risk, and that's that if we don't do anything about it, we'll get superseded by a power that has a political system that has values, I think, that maybe few of us share. I don't know about it, but I feel that. But I think there are other risks, and they have to do with the so-called AI control problem. And let me just explain what I mean by that, because there are some different kinds of them. The one was the one Microsoft. The idea, how do we control a super intelligent AI? So imagine an AI that's like God. It can think much faster and quicker than any one of us. How do we control it? Well, I think that in Bostrom and others made a very compelling case that we can't. There's no way of controlling it. So they argue that the only way to ensure that an outcome where an AI like that exists is not going to lead to a disaster for everyone, is to make it friendly. So in one sense, this idea is not about controlling a super intelligent AI, but rather by giving it certain motivations that are coincide with our own. I'm going to set that aside, I just published an article, or it's in press, where I explain why. But in essence, I think that the super intelligence scenario is very, very unlikely, and that there are much more pressing problems that we should think about right now, or at least that you should be thinking about. I'm not saying this to be condescending. I think you have really good skills, and there are some problems that you can solve much better. I think the super intelligence problem is mostly a philosophical problem, to the extent that it is. And I think that I and other philosophers might be better suited to deal with that at this moment. Who knows in the future? Maybe then we'll do that. In any case, I don't think it's a big problem. The other control problem, and that's the one I want to talk about a bit, is this control problem of narrow AI, or the kind of AI that we have in cars, or self-driving cars, and other automated systems, logistics AI, and so on. I think that the control problem can be kind of split up into three sub-problems. And I think a lot of you might be aware of this, but so first of all, it's that artificial neural networks are to a large extent black boxes. There was a recent article in Science, Journal of Science, where one AI researcher, I can't remember his name, but I can send you the link afterwards, wrote an article about that he claims that AI research is not science, it's not even engineering, it's alchemy. And let me just qualify that. Maybe you don't see. Saying that something is alchemy, it's not saying that it doesn't work or that it works. To the contrary, alchemy was really, really good. I mean, they developed gunpowder, they developed glasses, they did huge advances in metallurgy. Alchemy set the foundation for science. It was alchemists who developed the scientific method. It was alchemists who developed laboratory techniques, and it was alchemists who, created chemistry and biochemistry and geology. So alchemy was a very good start. The problem was that alchemists didn't understand what they were doing, and that's why they kind of, they could do this fantastic new gunpowder without smoke, but I'm just making this up. I don't know the details, but they thought that to make it, you need to do it when it's when the room is full, and you need to have a bull in the laboratory, and you can't have talked to a virgin for a whole week or so on. So it's like they could do stuff, and they did them competently, and they understood that there was a lot of weird things going on here that made doing stuff, and there was a replicability crisis in the business of alchemy in the 17th century. So they knew about these things and they tried to improve them. But the fundamental problem was that they were still working on the paradigm that there were four elements: earth, wind, and fire, and everything was about combining them in the right way. And this guy in Science, an AI researcher, claims that this is basically the stage where AI researchers begin. So why the hell does artificial neural networks work so well? I mean, how is it even possible that we can get such accurate recognition of images? How the hell can they do these things? Well, there doesn't seem to be any good theories that are widely acceptable of how this can work. So, and I think this is fascinating for me as a kind of philosopher of science. I think this is like, whoa, this is what a moment to be alive, to see this paradigm unfolding and becoming a real research. But we need to, I think everyone needs to know that it's still in its infancy with regards to the theoretical understanding of it. And that means that it's not only that particular AIs are black boxes. In one respect, the whole field is a black box. And this, of course, creates a lot of risk, because if you're going to put a field into the control of the state, then you don't want it to be a black box, right? So I think that's going to be a challenge if our ambition is to, put this in charge of this. Number two is that so this is kind of the big problem. Other problems are derivative of this. If you could understand how AI works, if we had a complete theory of artificial neural networks and had a possibility to debug and to fully grasp what's going on there, then other problems would be much less urgent. And I think we need to solve that problem, of course, but other problems can also be, need to be addressed or solved in parallel. And the second problem is that the data that we feed to a network can be biased, and is very often biased. And how do you know that data is biased? Well, you can know that data is biased if you're not biased yourself, right? If you realize that not all people in the world are white men, then you might realize that the data set I'm feeding this seems to be incomplete. How come my image recognition system? So you could spot those. But if you are biased, then you're not going to be able to see it. So creating an unbiased system, and I mean this is an obvious example, but the problem is that data could be biased in really a lot of different ways. Not only with regards to image recognition, but it could be biased in the sense that you have like self-driving cars that are biased towards the average pothole size in Nevada. It seems like the average pothole size in Ethiopia is different. You know, they have no cars; they have no pothole. Not just kidding. No, yeah, they actually built a lot of highways recently, and nobody can afford a car, so the roads are pretty good. But there's a lot of sadness. I just recently read about this. So it means that your AI system is biased, and you can only debug it, or you can only debias the data if you're debiased yourself. And of course, we're all biased in some extent. So that's like a way. That's a difficulty of how to control, because what you're doing here is that by controlling the data, you're also indirectly controlling the output or the behavior of the system. And by failing to do this, you're also losing control of the output. And secondly, and I think more importantly, is that autonomous systems that learn from interactions with the world are going to, by definition, have learned things without you being able to control how they learn them. So do you remember Microsoft's Twitter bot tape? So there was Microsoft had this Twitter bot, and they were supposed to learn from interactions with other people. And then there were a lot of Nazis from 4chan and Reddit, I think, that made a coordinated attempt. They coordinated and talked a lot with it. And after 24 hours, you got a Twitter bot that was anti-Semites and very misogynistic and very nasty in many respects. And this is maybe too good of an example of how Microsoft lost control of their AI. Not because the data in Chrome was necessarily that bad, I actually don't know, but because it wasn't.
Yeah, it was meant to be that.
But maybe it was not the badness of the data that caused the problems that we could see. I don't know. I don't know the details. But in any case, they lost control of how it interacted with the world, and this led to it displaying behavior that was not. So I think that this is kind of the control problem. It has its three aspects. I'm not going to talk further because I hope you have some questions. So how to solve the question problem? So there are kind of a three-pronged strategy, and this is kind of where my thinking is not really settled yet. So I'm not well, it's never settled, but this is kind of the least settled part of my and I think that there are three main strategies. One is controlling the motivation of the system. What does the system want to achieve? And I think this is kind of, at least among people that I've talked to, seems to be the mainstream approach. You want to design a system to be unbiased, to be a good bot, be a good car that will not kill people, that knows the right answer to the problem. So it's about making motivations in the system. I think that this approach is flawed, not necessarily in the sense that it's a bad approach, but it's a clearly insufficient approach. Partly for some of the reasons that I mentioned. That the problems surrounding the control problem, I think, is much deeper than a lot of people in the field, and certainly almost everyone outside of the field care to recognize that the control problem is no, I wouldn't say fundamental, but it's a deep problem, and that creating the correct motivations is going to be very difficult to make that sufficient to address the problem. Because even if you have a really good motivation, if you can't control other parts, you might still end up with that anti-Semite response, even if it was done to begin with. Unless you kind of predict that somebody's going to make your bot into a Nazi, but then you might not predict that somebody's going to make your bot into authoritarian communist or to religious fanatic, or so. I think the second and third approaches are perhaps more to the point, and I think that feeds back into the thing that we talked about first about AI is political. The second approach is limiting what AI can do. And I think in one sense this is kind of a very worrying thing for me to say, because what we want with AI, that's the kind of that the big kind of hope or the big idea with AI is that this is a limitless technology. You can have a self-driving car, and that car could take you anywhere where a human could take you. And that's kind of the alluring, the potential that's so powerful. And by limiting it, I'm just simply saying, imposing either legal or technical checks and restrictions on what AI can do. So one way of limiting self-driving cars would be saying, so you can drive on these roads, on these specially designated roads, or in this special area. Or you're allowed to do these things, but not that, or something like that. Or with lethal autonomous weapon systems, limiting means simply putting a human in the loop that makes the final call to the trigger. So that's another way of doing it. And of course, it kind of takes out some of the sparkle with AI, some of the kind of magic potential. But I think that until we solve some of these deeper issues, the limitation is going to be the most effective approach. And the third one, and I think that's kind of one strategy that I've just recently started thinking about, and I think it has a lot of potential. It's about the human side of teaching humans about how AI works and teaching them how to interact with AI. And creating AI that perhaps has better opportunities to signal to humans when it needs to. So let me give you an example from a self-driving car system. So imagine that you want to cross the street here downtown. So what you typically do is that you look at the car and you see, you make eye contact, or you see some kind of very subtle signal from the driver that he or she intends to slow down. And then you can safely pass. Or you can see that this person does not want to slow down, and then you stay on the sidewalk. In either case, you can read the person coming in the car. And the person reading in the car can also read you, because they can see that you're distracted, so they can see that you're looking at your phone. And even though they have to brake kind of hard in a way that's uncomfortable, that you do not have to do had you not been looking at the phone, it can still brake hard because it knows that you're so distracted that you're not going to be able to play this social game with the driver. Okay. So how would a self-driving car solve this problem? Well, it's going to be a really difficult problem for a self-driving car, unless it has a lot of additional AI systems like face recognition and other kind of behavioral recognition systems that are just really difficult to program. Not only because it's difficult in itself, but because people vary and people have different signals. In Stockholm, people behave in certain ways when they walk across the street. In Morocco, where my father's from, they behave in a different way. So one way of making this much easier, this problem much easier, is to allow cars, self-driving cars, to signal to people that now I'm going to drive, so you better stop by flashing a green light or a blue light, right? And allowing people, teaching people how to behave, to clearly communicate their intent to the machine. Maybe it's waving, maybe it's showing a card with some color, or maybe it's standing in somewhere. Maybe it's you're not supposed to stand close to the road on the sidewalk. Maybe you can have signs there. So this means that we need to develop AI that is in a sense smarter than understands us better. But that's a difficult task. So we need to do that. But with that task can be made less difficult to teach humans on how to behave in relationship with AI, and that way we can evolve together into a mutually beneficial relationship. Because I think that's the end goal. So yeah, sorry, I've been talking really fast, and I try not to do that because people feel discouraged from asking questions. But on the other hand, we get the people to ask questions now. Okay. William.
So the question is, I mean, I think really good talk, but I think one thing that's so interesting is we talk about it's like we have different perspectives. One is like right now, and then we have the future, and I feel like it's thinking like how we can solve this problem in different ways. I think so. My sister is a medical doctor, and we're talking about how we can use machine learning in medicine, and we're talking about for cancer screening, for instance, and said that, well, and we thought about like, oh, how can we do it in a safe way? And well, and we just talked and said, well, what you can do is you can just make it so you have machine learning systems that screen first and say these are the things that are most important, and then someone else look at that. And that seemed like, well, that's actually a good solution. Yeah. And I think in Sweden we had a system for machine learning for deciding who will get benefits, and the people who gets the benefit are going to be automatically selected by machine learning system, and if they get denied, that's going to be made by a professional. But for me, that seems like a good solution for at least for short-term problems. I guess not in related to self-driving car, but in general, that kind of like first having a positive signal from the machine learning system, send that to a human. But that seemed like a pretty good solution, or like a practical solution. Yeah. What do you think about?
No, I think these are really good things. The reason why I emphasize this kind of back-end approach is because of Microsoft neglected it.
Right.
Almost every person in tech that I know and I talk to are working with front-end solutions in this respect.
Yeah.
And they're working with apps.
Yeah.
They're working with making image recognition systems for specific cancer things and so on. And I think this is great, but I think that if you're starting to think about what ideas should I choose now, then you're more likely to succeed if you're not competing with a lot of people. And I think that when it comes to this kind of more abstract back-end perspective, I know that there's almost nothing in that. I have a friend who works or used to work at the public pension system. Mm-hmm. And they're like using techniques from the 90s. I mean, it's ridiculous how primitive it is. And they have they're trying to solve a problem that's very readily, so they want to predict how many pensioners need to receive money next year. So they need to make a budget. And this is a complex problem because you need to account for how many people are going to die, how many people are going to survive, how many people are going to become pensioners, are they going to move to another country, and so on. So it's like, but it's it's a problem that you could really solve much better with AI. But they're using like very old school statistical techniques. So Marcus, and then you, and then someone.
Okay, cool. So at one point you said something along the lines of like not worrying too much about AGI. So I want to dig into that a little bit more, and basically understand what you're actually saying. So when it comes to, are you saying there that like, so like over the recent years, like we've had super intelligence published, we've had like all of these different like research institutes like pop up that try and like solve this issue of like, how do you make sure that like in the long term, AI like is used for good or something like this, that like with some kind of idea that like there's like some chance that we'll get like radically transformative AI, and how do we make sure that that's beneficial? And I guess I have like two questions there. One of them is like, where do you disagree with that picture? Is it just sort of like, is it more like a philosophical quibble of like the definition of AGI, or is it about like the sort of the practicalities? First question. And then the second question is like, you said something along the lines of like, we can't solve this problem with like, we can't do technical stuff yet. But what about the like safety teams at like DeepMind, OpenAI, etc. that are like have started the past few years?
So first, I don't think it's just a semantic or a word play question. I think that kind of philosophical disagreement is just very annoying.
Yeah.
No, but what do you mean by disease? Oh, I mean this. Oh no, you should mean something else. Yeah. And I think that's just no. What I'm saying is that so first of all, I think that Hofstrom is wrong with regards to the risks. I think it's much smaller risk that will get super intelligent, right? And I'm really happy. So I have this paper, and really happy to send it to you. And I really want to comment on that. Yeah. So I can. But and secondly, I think that even if it was true, then I think that his approach is really bad. So the approach is to create friendly AI, because he's already assuming that it's going to be possible to control something that's super intelligent. Yeah. And I think that's just a bad solution. But thirdly, I think that even if it was if it was right and friendly AI was a good solution, I think that that solution is not. It's that the problem is so ill-defined, and the solution is so ill-defined that it's still in the realm of philosophical speculation. So one way of thinking about what philosophy is, or what it should be, is that we should take things where very ill-defined, very badly formulated problems, and we try to think about them and systematize them in a way that actual researchers and scientists can start working. And this is how the kind of history of philosophy looks like. I mean, almost all the subjects used to be philosophy. Then they were kind of, the problems were formulated better and better, so actual researchers could start working. And I think that's where we are with the super intelligence. But going to the question that you talked about, DeepMind and OpenAI, so I think a lot of the stuff they're doing is pretty good, but a lot of it, I think that almost, and some of it's philosophy. But I think that the part that is good that is not philosophy is mostly about the control problem with regards to scenario AI, because they're doing that too. And especially OpenAI, I mean, Elon Musk has been talking a lot about, how do we ensure that we don't get AI that we can't control, not because it's super intelligent, but because it interacted with the world in a way that's really messy. And now we have an outcome that we didn't want. So I think that's a good problem for technical people to work on, because that's much more well-defined, not super.
In terms of this sort of ML type, or this critique of the Bostrom, that so the critique roughly, so I don't do these things, so I'll try and still explain. So the critique is something along the lines of Bostrom assumes the problem is we have this super intelligent thing and we've got to tell it what to do, and it's super difficult to do that. And one development since 2015 when this was published is that people realize oh shit, we don't even know how to create something where we would be able to put in the code. And so that's a general way in which this talking about super intelligent AI has changed. That we talk less about that problem and more about sort of super intelligent AI would be based on machine learning, in which case it wouldn't have neat goals. And my understanding is that those people generally still think that you have this fairly large risk of the sort of this long-term sort of fairly large risk.
So one interesting thing, it's kind of peculiar, but if you read super intelligence, you will notice that it talks very little about machine learning and AI. It's kind of a sideshow. And why? Because he wrote that book in 2010. And academic publishing is hell, so that means that your book is not going to come out until 4 hours later. So he didn't see that this was going to be a big thing, and very few people did in 2000. And I think a lot of people today that I talk to that are concerned with AI, that take this really seriously, very few of them think that machine learning is going to become super intelligent anyway. They think that machine learning is it's another hill, it's another road. It's not going to lead to super intelligence. It's a really cool road. We're going to do a lot of powerful and interesting and potentially dangerous things, but it's not. That's not the super intelligence. And okay, so this is kind of going a bit outside. I think we can go back to this. If you had a question, and then you.
I forgot many questions, but I just wanted to make a question. One about the black box that you said, and the second one about the bias and the ability. About the black box, first of all, according to my knowledge, machine learning is just like 20% about neural network or something, and 80% other things, which are quite clear how they work.
Right.
That 20% is quite clear as well. But again, in my experience, when we said that neural network are kind of black box, is not a real black box. And you know what's happening. Oh, it's something weird. No, it's not. It's a mathematical algorithm. Yes, you can't just go there and say, okay, then maybe 25th multiplier, so this node has this, but you can do them this way too. So because of this, it's a kind of black box. We say like maybe a little bit more black box than the other. So I personally do an expert in this, but I don't do that machine black box at all. So anything that we design, we know how it works and we know why it works like that. That's the first thing, and it's just like this. When you use a computer or laptop, you don't know how electrons goes in one transistor or in microchip. But do you really need to know that for a user? No. It's just enough for you to know that it works in a way that you want. So, because I don't understand when you mentioned that it's a black box, so we can't trust that. It is. And it's not just you, because I'm reading this kind of articles many times, and we're the first guy in this field that I did, so
yeah.
I really appreciate
so I think you have a very good point. So I want to qualify what I said. So first of all, yes, it is true that I'm talking about the machine learning. So yeah, let's do that. Second, I totally agree with you that, I don't know how this works. And it's not like this will risk. It's dangerous to me because I don't know how it works. So a lot of non-AI systems are opaque to a lot of us. The difference, so it's not a difference in kind, it's kind of a difference in degree. So the more, so it's kind of it's more black boxy than good old-fashioned AI. But the increased level of black boxiness has, and I'm not an expert in this, so I have to trust what I read. But a lot of people who I've read that I think are experts are concerned about. And let me give you an example from this article, and I will post the link. I can post the link in the event so everyone can find it. It's from Science, and it has a lot of fun examples. Like there was this team with a translation algorithm in French and English, and when they kind of removed the core of the program because they wanted to test some of the bells and whistles of the program. It turned out that it could do the translation even better. I mean, you could take out 80% of the code and it would still do the work, and it would do the work even better. And this is what's going on all the time, that you have lots of code, you have a lot of techniques to fine-tune the algorithms, to do kind of a stochastic gradient stuff, which is kind of basically just trial and error. So these are the things that they need when they say that it's a black box. But it's not like engineering when you or science when you know that if I do A, then B will happen. It's like if I do A, something will happen, so I do A plus 1, and then B A plus minus 1. Okay, this is maybe good enough, and then so that's the kind of problem, and that's kind of compounded by the whole thing that's supposed to be done. Are we running out of time?
I think
yeah.
so.
Okay. I think we just
maybe one more question.
I have one more question. Okay. Yeah. I can be very short.
Yeah.
I just want to say, like, also, of course, after the talk, you can also keep talking, so there won't be like the end of the world. But of course.
Just a quick question. This is more about the trust issue and also what you said about the public administration. I think that the trust issue is something that must be broken to get to the public administration. In my experience, I am a medical doctor and in this crowd, but I'm working with big databases, and I found that machine learning is going to solve a lot of my questions better than regular old statistics. And then for me, trying to drive this point to the old physicians in the hospital is quite hard. So I've been trying to come to this, trying to get above that trust issue. And then one of the questions that comes every time is the question of regulation. And then the doctors are kind of trust something that we can like assign the blame to. This fails, who is to blame? What, like if I use this algorithm to get to diagnose the patient failed, I know it's not be accurate 99% of the time, but that one time that it failed, the patient dies, something happens. Who is to blame? The algorithm, the doctors, the hospital, and that kind of regulation where I don't know, but I think we're not there yet, and that's maybe like the first step or the lowest hanging fruit that we need to say what is it?
No, I totally agree. And I've been talking about the lawyers too. The problem is they don't understand it. They understand what it is. And I'm trying to explain, but I think sometimes, what you can do much better than me is not just talk, but show. You know, show, don't tell. And I think that, I think that might be the reason.
I think so. Thank you so much.
Thank you.
We can take a short break and then we have the next talk. So I just want to say, like, it's really interesting questions to bring up, and I think, of course, we're working. One of the tracks is trust in AI. So, like, these questions we're talking about, we're going to keep talking and working on them. And I think I'm not sure what the goals are, but I think one thing I was thinking about was a short-term thinking about from this thinking together, and I guess coming from different fields, we can write something and think about like how should we work with trust in AI, what are good ways to work with that now, meaning thinking like how are good ways to implement machine learning in systems today that reduce risk. So that was something I was thinking about inspired by your talk. So, but let's take a short break and then we can have the next talk. Thank you.
I think it's built on what you said. Yeah, and we can also here. What we're doing is that we're not writing everything from scratch. We're starting to reading some of it and discussing as we go on in this discussing the section of this paper, and then summarizing this in different small groups. Think about what it's about, what the analysis is, that we can centralize and then do some coding. Cool.